We took a good look at the thyroid cartilage and the cricoid cartilage in the last section. As we saw, the two cartilages articulate here. When the arch of the cricoid moves up and down, the top of the lamina moves backward and forward. The two cartilages are held together at the front by the strong cricothyroid membrane, which is part of a larger structure, as we'll see later. Now we'll add the epiglottic cartilage to the picture. The epiglottic cartilage is shaped like a leaf, with a slender stem that's attached here to the thyroid cartilage. The epiglottic cartilage is also attached to the body of the hyoid bone by fibrous tissue that runs through this pad of fat. The epiglottic cartilage is covered by mucous membrane here on the back and on the front down to here. The epiglottic cartilage is highly flexible. Next we'll add the arytenoid cartilages to the picture. Here they are. The arytenoid cartilages, which are highly mobile, sit on top of the lamina of the cricoid cartilage, just to each side of the midline. They articulate with the cricoid cartilage at these two surfaces. Here's the right arytenoid cartilage seen from behind. This tall upward projection is the colliculus. This pointed forward projection is the vocal process. The vocal ligament is attached here. On the underside, this inward-facing articular surface articulates with the cricoid cartilage. Next to the articular surface, this projection on the lateral aspect is the muscular process. Muscles are attached to the muscular process and also to the lateral border and to this broad convex surface which faces forwards. The top of the colliculus is prolonged by this tiny corniculate cartilage which faces backwards. In the intact larynx, the arytenoid cartilages are here. When seen from the side, the arytenoid cartilage is here, with the vocal process just in line with the vocal fold. The arytenoid cartilages can move laterally and medially, and they can rotate about a vertical axis. When the muscular process moves backward and forward, the vocal process is abducted and adducted. Here are the vocal processes of the arytenoid cartilages. We'll add the vocal ligaments to the picture. Here they are. The vocal ligaments run from the thyroid cartilage in the midline to the tips of the vocal processes of the arytenoid cartilages. They're fixed in front and highly mobile behind. Their tension is affected by the tilt of the cricoid cartilage. The gap between the vocal ligaments is affected by rotation of the arytenoid cartilage. The vocal ligament isn't an isolated structure. It's the free upper border of this cone-shaped sheet of membrane, the conus elasticus. The conus elasticus is attached below all the way along the upper border of the cricoid cartilage. Its upper border, which is free from here to here, forming the vocal ligament, is attached further back to the arytenoid cartilage. The anterior part of the conus elasticus is firmly attached to the thyroid cartilage, forming the cricothyroid ligament, which we saw earlier. Here's the right half of the larynx, with the mucous membrane intact. The conus elasticus is just beneath the mucous membrane, here. The mucous membrane is closely attached to the vocal ligament and also to the inner aspect of the arytenoid cartilage. At the level of the vocal folds, there's a narrowing between the walls of the larynx. Its anatomic name is the rima glottis, but in this tape we'll refer to it as the vocal opening. Its shape is extremely variable, depending on the movements of the arytenoid cartilages. Here's the vocal opening in a living person, seen from above. In quiet breathing, the opening is diamond-shaped. When we breathe deeply, it widens to a triangle. When we speak or sing, it narrows to a slit. When we hold our breath, it closes completely.